Let's talk about some different ways that our router can boot up. One thing the router could do, it could boot into ROM monitor mode. What is ROM monitor? Well, ROM monitor is a very basic operating system built into our router. We might use it to do troubleshooting. We can do things like password recovery. But when we're in ROM monitor mode, the router is not really acting like a router. It's not able to do any routing. Another option is to boot from the first Cisco IOS image that the router finds in its flash memory. If we have more than one, this option would let us pick the first one. However, what we typically do is in the router's configuration, we specify, here's the Cisco IOS image, typically located in the flash of the router, that we want to boot from. And of these three options, it's something called the configuration register in the router that determines whether we boot into ROM monitor mode, or we pick the first Cisco IOS image in flash, or if we get our loading instructions from the configuration in non-volatile RAM. Let's talk for a moment about this configuration register. The configuration register is a 16-bit value, and here we see the layout of those 16 bits, but our main focus is going to be on the first 4 bits. Bits 0 through 3, the numbering starts at 0. These 4 bits make up the boot field. And the configuration register, it's always written in hexadecimal notation, and with 16 bits in the configuration register, that means we're going to have 4 hexadecimal digits making up our configuration register. And there are some interesting things we can do here using Cisco documentation as a guideline. We could set the console speed by setting bits 5, 11, and 12 appropriately. If we're wanting to do password recovery, we could set bit 6 to a 1 to say we want to ignore the configuration containing the password in non-volatile RAM. But again, we're just focused on the boot field, which is 4 binary bits, meaning that it's 1 hexadecimal digit. And the way we write hexadecimal numbers is we start with a 0x. That 0x prefixing another number is simply saying that that other number is a hexadecimal number. Don't try to read any mathematical significance into 0x. You don't need to ask, well, is it sometimes 1x? No, 0x is just a big label saying what is to follow is a hexadecimal number. And we're focused on the rightmost hexadecimal digit in our configuration register right now, the boot field. If that rightmost hexadecimal digit in our configuration register is a 0, we're instructing the router to boot into ROM monitor mode. If it's a 1, we're saying that we should boot from the first image in flash, or if it's any number in the range of 2 through 15, in other words, F in hexadecimal, we're going to look to the NVRAM configuration to get our loading instructions. We're going to look for a boot system command to say, boot from this Cisco IOS image. A really common configuration register value that we see is 0x2102. That's probably what you've got on your production equipment right now. 0x, again, just saying what is to follow is a hexadecimal number, so let's not even consider the 0x because, again, it's just a label saying what is to follow is a hex number. And in hex, we have 2102. We know that each of these hexadecimal digits is made up of 4 bits, so let's break them out. If we take the 2 and break it into 4 binary numbers, that's going to be a 0010 in binary. If we take the 1 and break it into 4 binary numbers, that's going to be a 0001. The 0, obviously, in binary is going to be all zeros, and the 2 is going to be 0010. These are the 16 bits making up our configuration register. You can see why it's easier to write this in hexadecimal notation. But let's focus in on that boot field, the rightmost hexadecimal digit of a 2. Since it's a 2, if we look at our table, that says that we're going to get our image loading instructions from the configuration in NVRAM. That's the way things normally work when a router boots up. A router boots up and it looks for the boot system command in NVRAM, and if it doesn't find one, then it tries to boot from the first Cisco IOS image that the router finds in flash. If there's no Cisco IOS image in flash, the router then attempts to download an image from a TFTP server on the network. If an image cannot be found on a TFTP server, after 6 unsuccessful attempts, the router is going to boot into ROM monitor mode. Let's see how we can tell what the configuration register value is on a router, how we can change it, how things differ if we change it. Let's go into our router console connection right now and check it out. On a router, we can see what the configuration register value is currently by doing a show version command. If we take a look at the bottom part of the show version output, it tells us very clearly in this case that our configuration register is 0x, meaning this is a hexadecimal number to follow, 0x2102. We're interested in that rightmost digit, the 2 in hex. That tells us, are we going to boot into ROM monitor mode? Are we going to boot from the first Cisco IOS image in flash? Or if that value is in the range of 2 through F, F in hex is 15 in decimal, if we're in the range of 2 through F, we're going to look into our configuration in NVRAM to see if there's a Cisco IOS image boot instruction there. And in this case there is. Let's take a look. If we do a show run on this router, we can scroll down just a bit, and here we see it, boot system flash, and we see the name of the Cisco IOS image that resides in flash. Now here I'm just giving one boot system command, but if you had different versions of Cisco IOS, for fault tolerance, you could absolutely have more than one boot system command, so if the first image was not available for whatever reason, you could go with a backup image. Now let's pretend that we want to go into ROM monitor mode. Why might we want to go into ROM monitor mode? One thing we can do there is we could set the baud rate for our console. Now we could use those 16 binary bits along with some documentation at Cisco's website and figure out exactly which bit combinations in those 16 bits would give us a certain baud rate on the console. However, it's a lot easier to just set it up using a little wizard that's built into the ROM monitor mode. Let me show you how to get to ROM monitor mode. What we're going to do is set the configuration register such that that rightmost hexadecimal digit is a 0, which tells us to boot into ROM monitor mode. Right now, our configuration register is 2102. Let's set it to 2100. A 0 is going to be in that rightmost hexadecimal digit position. Let's go into global configuration, and we'll say config register, and we'll give in hex 0x to say the number to follow is a hexadecimal number, 0x210, not 2, but 0 in this case, 2100. We can see by looking at the show version output again that this is going to be our new configuration revision number once we reboot. You see it says right now we're 2102, but after a reboot we're going to be 2100. Let's do a reload right now, and I'll not save my configuration. Let's do a reload, and this is going to take us in to ROM monitor mode. I sped things up a few seconds for you right there as we were going into ROM monitor mode, and here you can tell by the prompt that we're in ROM monitor mode. We still have context-sensitive help. These are the commands available to us. The command that I'm typically going to be using here is this confreg command. This is the configuration register utility. Instead of having to do all the binary math to figure out here's the baud rate and yes I want to ignore the NVRAM config or no I don't, or here's how I want my IP broadcast address to be formatted, I can just go through this utility. Let's say confreg. Do I want to change the configuration? Let's pretend that yes I do. Yes, I do want to change the configuration, and we'll just keep the current setting for most of these values. One thing we do want to do is we want to set the configuration register back to 2102 so that we will be paying attention to the configuration in NVRAM when we boot up the next time. Here's where we could set the console baud rate. If I did want to say I want a different baud rate, I could say yes, and we could pick the rate, and it would set bits 5, 11, and 12 appropriately in our configuration register. I'll just take the default of 9600 baud. Do I want to change the boot characteristics? Yes, I do. Notice if I say a 0, which is what we configured just a few moments ago, that's going to boot us to where we are now, to ROM monitor mode. What we want to do right now, though, is boot up and pay attention to the configuration in NVRAM. And I'll enter a 2 to say that. We could enter a value in the range of 2 through 15. I do not want to change the configuration anymore. I'm going to do a reset. And when I do that, the router is going to boot back up. This time it is going to be paying attention to the configuration that it has in NVRAM. So it's going to be back to the way it was when we began. But what this has been demonstrating for us is that we can go in and view the configuration register, we can change the configuration register, and we often change the configuration register to say that when we boot up, we're going to boot up into ROM monitor mode. Once we get there, we can run the confreg utility to set things like the console speed. And while we're there, we can set the configuration register value back to where we will be paying attention to the configuration stored in NVRAM the next time we boot up. And that's what we're doing here. Cisco routers and switches have their own file system. It's called the IFS, the Integrated File System, and the IFS gives us different places where we can store files, such as a TFTP server. If I'm upgrading from one version of Cisco IOS to another, I might download that new version from a TFTP server. I could store files in Flash. In fact, when I download a Cisco IOS image from a TFTP server, I'm probably going to store it in the router's flash memory. I might have files in the flash that allow me to have the router act as a web server, so I can point to my router with the browser. And we don't just have to copy files to these storage locations, we can copy from these storage locations. For example, I might want to make a backup of my configuration on an FTP server. And our startup configuration that's used when the router boots up, that's stored in non-volatile RAM. And these are just a few examples of possible file system locations inside of our router or switch. There are several others that we might have as well. We might have a USB storage location, other types of servers to which we could copy files to and retrieve files from. And let's now demonstrate some of the different commands we could use to navigate around this file system structure by going out to a live interface. Let's begin on this router by taking a look at what file systems we have. We can do a show, file, systems to see what's installed in this router. Again, different routers might have different options. You might have a USB option. Here we don't. Here I do have internal flash. We've also got NVRAM, non-volatile RAM. That's where our startup config is stored. We could also copy to or copy from an FTP server, a TFTP server, other options you see there as well. And the way we're going to navigate in this file system, it's almost a mixture of MS-DOS and Linux or Unix. Some of the commands we might find in DOS, some we might find in Unix, and some are unique to Cisco IOS. For example, if I want to take a look at the contents of my non-volatile RAM, I could say dir, just like we would do in MS-DOS. I could say dir nv ram : and I can see the contents of my NVRAM. Here's my startup config that gets loaded when the router boots up. Another way to look at the contents of one of these locations is to do a show command. I can do a show flash : to see the contents of flash, and we can even create directories if we want to organize our files. Much like in a computer operating system, we can create a directory structure. The command to create a directory is the same command we would use in Unix. It's make directory, mkdir. Let's say make directory, and let's just call it output as an example. Make directory output. Do I want to create that directory? Yes, I do. Now, if I do a dir to take a look at my files that I have in Flash, that's the default location we see when we just do a dir and don't specify a location. You see that in addition to a couple of Cisco IOS images and a music on hold audio file, I've got a directory called output. How do I know it's a directory? Well, if you notice this D flag, that means directory, and RW, that stands for read-write. I've got read-write privileges. And I can go into that directory if I want to. I can say CD for change directory into output. I can do a dir here, and you'll see that there are no files currently in this output directory. I could see what directory I'm currently in by doing a pwd, a present working directory. That's a Unix command. And let's put a file here so I can show you how to delete it. One of my favorite Cisco IOS commands is show IP interface brief. What if I wanted to store the output of that command in a file? I could do it like this. I could say show IP interface brief and then give the vertical bar that's called a pipe symbol. I could pipe that to redirect and say I want to redirect the output to Flash in the output directory. I want there to be a file called int_brief. Let's redirect the output there. Now I'm still in the output directory. If I do a dir, there's my file, int_brief. If I want to see the contents of a text file from this file system, I can do a more command. We can say more int_brief, And that's the contents of that text file. I can delete that file by saying delete int_brief. We'll confirm that we really want to. If I want to get back up to my parent directory, I can say cd space ... That takes me up to the parent directory. A PWD shows that I'm at the root right now. And now I can remove that output directory. I can say rmdir for remove directory / output. Actually, no slash. We'll just say remove directory output. And yes, I do want to remove it. So now when I do a dir, you see that it's not there any longer. And we've taken a look at a couple of storage locations on the router. We took a look at NVRAM, we took a look at flash, but we could also copy to and from an external server, such as a TFTP server. Let's see how we could do that. Maybe I want to make a backup of my startup configuration. I could say copy, and this is like you would use a copy command in most operating systems. You say copy, and you specify the source, what you want to copy, and then the destination. To where are you copying? Well, I'm going to copy startup-config to a TFTP server. And it's going to prompt me for the IP address of the TFTP server. In my case, it's 192.168.1.50. It's going to suggest a destination file name. I'll leave that. And it copies it. We see the 2 exclamation points. That shows the copy was successful. And we see that we copied almost 6 kilobytes of data to the TFTP server.